This is the video lesson for balanced versus unbalanced forces. The learning target for this lesson is, I am learning to understand what balanced and unbalanced forces are and to determine when forces are balanced and unbalanced. The success criteria for this lesson are, I can understand what a balanced force is, I can understand what an unbalanced force is, and I can determine when forces on an object are balanced and unbalanced. So let's look at unbalanced forces. So here we have a diagram of a person pushing a box across the ground. So let's look at the balanced forces first. So we have gravity pushing downward, and we have the normal force pushing upward. So these two forces are balanced. So gravity and the normal force are balanced. The arrows are the same length, which indicates that the forces are balanced. Now we have an applied force here pushing to the left, or to the right rather, and we have friction, which is opposing that force to the right, to the left. Now the applied force arrow is longer. It's a longer arrow than the friction force, and so that implies that the applied force is a greater force than the friction force. So this is unbalanced. What that means is that there's an acceleration. So the applied force is causing an acceleration of the crate or the box across the floor. So the box is either speeding up, or if it were moving in this direction to begin with, it's slowing down. But we're assuming that the box is moving in this direction, so it's speeding up from left to right. So here we have the same example of a person pushing a box across the floor, but in this case we have balanced forces. So again, we have gravity pushing down, and we have the normal force pushing upward. And so these arrows are the same length, so they have the same magnitude. So the gravity and normal force are balanced, as they will always be. So gravity and the normal force are always going to be balanced. We have the applied force pushing the box to the right, and we have friction opposing that force, the motion to the right. So the friction is opposing the rightward motion, and so these arrows now are the same length. So the force is balanced. So we have a balanced force, which means there's no acceleration on the box now. Which means that either the box is not moving, or if it is moving, it's moving at a constant velocity. So here we have a velocity time graph for the scenario with the box being pushed across the ground. So in this region of the graph, we have an acceleration. So here, this is because of unbalanced forces. So this is from this acceleration here. So this segment of the graph would be from the first diagram, when there was unbalanced forces. So the person is pushing the box to the right, and the applied force was greater than friction. And here in this section, we have balanced forces. So no acceleration. No acceleration. So we have a constant velocity. Constant velocity. So this would be the second diagram, where we have the applied force is equal to the friction force. All right, let's look at a second example of unbalanced forces. So here we have a skydiver. His chute is still packed in his backpack, so he's falling with unbalanced forces. So gravity here is greater than air resistance. So he's accelerating. Downward because gravity is greater than the air resistance. So he's accelerating because gravity is greater than air resistance. So these are unbalanced forces. In the second diagram, looking at the skydiver, here we've reached a state called terminal velocity. So in this case, our gravity is now balanced by our air resistance. So the skydiver is falling as fast as they can fall because gravity and air resistance are now balanced with each other. So we have balanced forces here. So we've reached a constant velocity. So we have balanced forces, gravity and air resistance are equal to each other. So gravity is equal to air resistance. Which results in a constant velocity. So balanced forces equal constant velocity. So here's a velocity time graph for the scenario with the skydiver. So here in this section of the graph, we have unbalanced forces. So this is when the skydiver is falling when gravity is greater than the air resistance. The velocity is increasing in a negative direction as the skydiver falls. Here in this section of the velocity time graph, the skydiver has reached terminal velocity. So the skydiver has balanced forces now. So they've reached a constant velocity. They're no longer speeding up. They reached a constant velocity. So the velocity time graph is a flat line. In this section here, this is where the skydiver has pulled their chute. So pulled parachute. Now they're slowing down pretty dramatically. So they're slowing down. So these are unbalanced forces. They slow down under unbalanced forces. So here, the air resistance is much greater than gravity. So air resistance is greater than gravity. So they are slowing down. So the parachuter is slowing down under the force of air resistance. And then this last little section of the graph is where the parachuter is falling down under the parachute at a constant velocity. So this is balanced forces, and a constant velocity. All right, everybody, keep asking questions. It's how you learn new things.